Hello and welcome to What is 3D Printing? This is the first video in our 3D Printing at the Library series. So what is 3D printing? Well, it's getting a lot of attention in the news and just around the world today, and it lets people create such a huge variety of objects. It's kind of hard to wrap your head around what kind of process could possibly let you do everything from shoes to jet engines to shapes like this to artificial hands, sculptures, gears, architecture. Well, 3D printing is essentially the idea of making things by building up material rather than carving it away. Carving it away tends to be the older way of doing things. You would start with a block of material and you would use some kind of a lathe or a milling machine to cut it. Well, 3D printing is additive manufacture rather than subtractive. Here is one of the 3D printers we have at PCCLD. It is about the size of a microwave oven. This is an older version, and here's our newer version. They're both great printers. They're both made by MakerBot. One was the Replicator 1 or the Replicator Duo, and this is Replicator 2. Now let's look at one of these 3D printed objects. Actually, let's look at a ton of 3D printed objects. These are all things that we've made over the years, past couple of years at the library. This is a small city sitting on the build plate of the Replicator 2. And if you look really close at any 3D printed object, you will see tiny layers. Each layer is essentially a flat picture of one slice of the object that was drawn with plastic on top of the previous layer. Now, if you look at the back of a 3D printer, you'll see where the raw material comes from. Raw material for our kinds of 3D printers, which print with plastic, come as a spool of plastic. Notice the end of the spool is feeding up into this little pipe, comes up over the top, and is plugged by hand into the extruder. Now the extruder is a small machine that can move left and right, forward and backward when the printer is operating, and it essentially pulls this filament off the spool and extrudes it through this tiny nozzle at the end. This is called the hot end. Rightly so, you will burn your finger on this. Think of it like a hot glue gun that draws with hot plastic. Here it is. This is the Replicator Duo. It actually has two extruders, a right extruder and a left extruder, and we can use it to print two different colors at a time. We can look at that later, but here is an example of how we used one head that was feeding green plastic and another head that was feeding white plastic. All of these objects were built one layer at a time, and it would build by printing all the white for a layer and then all the green for a layer, and then it would move down the platform one layer so it could print the next layer on top of it. And you can achieve such a huge variety of objects just by doing exactly that. We have a whole set of different colors that can be used at the library, ranging from, here's glow in the dark, very popular around Halloween time, bright red, and purple, great for printing Christmas ornaments, to just gray or black, anything you can imagine really. Here is a video of 3D printing in progress to give you an idea of what it looks like. Now I think that's a pretty good look at it. I want to back this video up a tiny bit and we'll look right in on the build process. Notice we're printing some solid objects. Well, they would look solid on the outside. The inside is filled with kind of a honeycomb pattern. That's something else, or something unique about 3D printing. You can actually print a lot of structure inside of things that are being printed. In this case, we use what's known as the infill to just fill up what would otherwise be empty space or solid space. When you set the infill lower, it makes the honeycomb pattern bigger. If you set the infill higher, so higher percentage, it makes it smaller honeycomb. The reason we do that is to save plastic and let the printer take less time to do its job. In most cases, the plastic is extremely strong all by itself, so it doesn't need to be a solid chunk of plastic. Here's some other examples of a honeycomb pattern inside of kind of a hexagonal block that we are printing. And this is a remote control car tire. Somebody brought in a project of a tire that was really a wheel with these spikes, and we kept a version that quit halfway through printing. So we ran out of orange filament, had to change it. This print was lost, but we kept it because you can see this fantastic kind of inner web work. That's the infill pattern. Something else to note about 3D printing is the generation of support structures. Since the process involves creating an object one layer at a time, each layer has to sit on top of the next layer up. This cat would start being printed by drawing a little circle for the base of each paw and move upwards. Well, what happens when you have an overhang? For instance, the cat's tummy right here overhangs by quite a bit. If the print progressed up to here and needed to print out into air and there was nothing to build on, you would just have a lot of filament falling into the air and turning into a ball of cotton candy. Well, the software that does the slicing for 3D printing, here's a preview of a sliced object, also generates support material. The support material is essentially a scaffolding, just like you'd use to build the outside of a building or something. It just builds this up. It prints and supports the structure for overhangs when it's being made, and then you can pull it off when it's done. It's typically not attached very strongly. There's also a raft. That's something else that's auto-generated, and you can think of it like a foundation. It helps the object stick solidly to the build plate when it's being produced. Now, objects that you make with a 3D printer could be printed for assembly, so you could print all these little parts of a robot. When it's done, you would assemble him into a finished little robot. Or, in some cases, you can actually print objects pre-assembled. Here's a great example. Here's a little elephant. Notice he has legs and a little head. Well, the head can swivel around so he can look left and right, and his little feet, his little legs can swivel forward and backward too. Another example is this car. If you look at the bottom of it, the wheels are free to turn, but there's no way to remove the wheels. In fact, we never put the wheels in. This car was printed with wheels already in place and free to turn. If you see these wheels, they're attached to each other by this shaft, and they go right through the body of the car. If you imagine this being printed, and this was printed on its side, just like this, you could imagine the car being drawn one layer at a time. So the first layer would be the car's side, and then a circle for each wheel. And the next layer on would be another layer for the car and a circle. The circles don't touch the car, and the whole thing grows upward. This column of wheel, shaft, and wheel could be thought of like a freestanding tower that was built, and the car was just sort of built around it at the same time. It's a real different way of thinking about building things. This is a great example of a gearbox that involves gears that were printed together, pre-assembled. I think it's very neat to see. When it was first printed, it was stuck together, and you had to put a pencil in and give it a really hard turn to essentially break it free. But after that, it was free to turn. You can print with a great deal of precision. Some 3D printers are designed to be printed on other 3D printers, and that includes things like the gears pictured here. This is a gear for a RepRap 3D printer. Here is a protractor, so you can print dimensionally accurate objects. You can print architectural objects. You can print kind of, creative or whimsical things you might actually use, or sculptures. The question then becomes, so where do all these patterns come from? Here's a city. How did this start? Did it start as a drawing? Did it start as a model, something somebody built first? Well, the blueprints for 3D printing exist as a 3D object. This is a picture of a 3D object file on the build plate to give you an idea of what it looks like. It's really a three-dimensional representation of a city, and it just includes geometry that can be viewed from any angle. This is the kind of object file that would come out of a program like a CAD program or a 3D modeling animation program for special effects. And when we're talking about 3D objects for printing, they really come from three different places. The first place is the easiest. You can download a number of ready-made, ready-to-print objects from a website called thingiverse.com. There are some other websites that let you do this too. You can 3D scan an object. We have a 3D scanner at the library. It's good for rather simple sculptural shapes. So in other words, things that have curved patterns to them, things with interesting textures that you want to pick up. The 3D scanner is great for that. And the third, and my favorite way of acquiring 3D objects is to directly 3D model them using a 3D program. There are a number of programs. One that we teach at the library is called Tinkercad because it's easy to pick up and works for, well, I'd say people that have no experience up through people who've got a lot of experience and just want something fast and easy to model with. So how do I print at the library? Well, if you have a 3D object that you've chosen, either on Thingiverse or you have one on a chip that you can bring in, you can just bring it in person, fill out the printer form, and we'll add it to our queue. You can also use our online website to fill in and upload your submission, and once we receive them, we'll let you know when it's done, and we'll call you for pickup, and there is a charge. The charge for 3D printing is a fixed rate of $3 per hour currently at PCCLD. If you want to estimate how long your print will take, there is a program called MakerBot Makerware. It's free to download and it has a really good preview function. So if you are in Makerware, you can find the space that would let you print preview and it will tell you how long it will take. And that's it for now. What is 3D printing at the library? Part of our 3D printing at the library series. I'm David, and you can go here, publiclibrary.org/ideafactoryhome for more information about our 3D printing. Thank you.